Kleinberg Wing Mark II development. I'm Ralph Kleinberg, your host. I know you don't get to see me often in the videos, and that's because I want to focus on the tasks at hand, which is development of this aircraft. But I thought I'd introduce a slightly different topic for today. What you see behind me here is the 7-foot test section that I made of the wing. This represents the section of the wing from about 1 foot outboard from the root out to about 8 feet at the tip there, so there's 7 foot of section here. And this was built for a variety of reasons. I built this in order to test out the construction methods and see how that process would go. I wanted to find out what the final weight would be, and by the way, this came out at 13 pounds originally, and it's getting heavier little by little. Just overall to see if the wing was durable as you handle it. Like, one of the things that I've discovered is that the wing surface is susceptible to denting by small objects. So that's an important thing in my mind right now, and I'm working on methods to prevent that problem. Of course, as you see here, the wing is heavily damaged, which is to be expected. This is a section of the wing that I built for testing. This has been load tested several times. It has been broken twice, and repaired 3 times. One of the repairs was this leading edge here. The early molding process that I used was not fully effective. I did not get a good bond between the Kevlar and the honeycomb core. I've now changed that process, eliminated the honeycomb core, and switched from Kevlar to fiberglass, and all of those problems have been resolved. But I had to do quite a few change-outs here on the leading edge. I had to strip off the Kevlar, put on some carbon fiber, and fill some spots. That was the first go-around of adjusting the design. Then the wing was dropped once in a test, and there were minor repairs that I did at that time. And then here we're looking at more major damage. This had probably, what do we have on it? We had several hundred pounds loaded on it out at the wingtip, and it dropped about 3 feet. So it took quite an impact. There was hundreds of pounds loaded on this when it hit a 2x4 and fell on the ground. And I thought that this provided a wonderful opportunity to test out repair methods. As you may be aware, I'm designing this aircraft for home builders. So that means not only does it have to be buildable and flyable, but what good is the aircraft if you can't repair it? And certainly if it's home built, you can't take it to somebody else to repair it. They won't have any idea what to do with it. My original wing, I built that to attempt to set the world's distance record for foot-launched aircraft. So I wasn't overly concerned with repairability on that aircraft. It was really meant for one purpose, and if it got damaged, I just took care of it. And I didn't worry too much about durability and repairability. This aircraft's a different animal, and I'm much more concerned about those 2 topics. So I thought I'd take a moment today to show you how I'm experimenting with different repair methods, and we're looking at some pretty heavy damage here, so we have some interesting processes to look at. I'll show you a couple that I did prior to starting the video. The rear spar was broken here, and the main spar was, shear web was cracked here, and this spar cap, which is on the lower surface of the wing, was broken in half. And the leading edge is significantly bent and damaged. So fairly significant damage. If you can see the root end, it's all cut open down there. Need not worry about that. I'm changing the design, and I've cut that open for change purposes. Really wasn't damaged at that end. This tip hit the ground. The other end was still semi-attached, and it just took a kink right here. Interestingly enough, the wing broke or got damaged just outboard of the leading edge tube. The leading edge tube ends right here, and the damage is just beyond that leading edge tube. So it's right where there was a stress riser, and that's to be expected, but interesting to see. So for the spar repairs, what I did is I removed any carbon fiber material that was not securely bonded to the foam core. Did that both on the inside and the outside. So I stripped back material that's not bonded to the foam. And then I repaired the foam quite easily with just some CA glue. I just got the foam, the one crack in the foam, glued it back together. And then I laminated on some more 2-ounce carbon fiber on the outside and on the inside, wrapped it up over the flange that was in there originally. And I didn't worry about keeping the wing straight in this case, or same methodology as the rear spar, stripped off the fabric that was not attached to the foam, repair the foam, and then put a double around here. And actually, I used some 8-ounce carbon fiber here. It's normally only about 5 ounce that's on there. It's extra heavy duty, and wrapped it around onto the caps so that it's a C-shaped repair. And I did the same on the front side. So right now, this is fairly strong, but the spar cap is not complete. We have a crack here that's been glued together, but obviously it's not going to be strong enough. So what I'm going to be doing is I'm going to be filling the length of this across the top with unidirectional pultruded carbon fiber rods, rectangular rods. I'm waiting for those to arrive via a nice postal service. And because the foam on this ring is an 1/8 of an inch thick, I ordered rods that are an 1/8 of an inch thick. And I'm just going to remove the outer surface, remove the foam, leave the inner surface attached to the spar, lay in the pultruded rods, and then put a new surface over the top. And I think that'll make a nice strong repair across that cap. But we'll find out when we test it. When we load it up, we'll find out if this holds together. The purpose of the video today was to discuss these repairs, and I was going to show you how I'm actually going to attempt to repair the skin. Obviously, hang gliders get bounced around a lot. They get banged into, poked at, hit a tree. You don't want to have to just buy a whole new wing section. That would just be obnoxiously expensive. If you bump into a bush and bent your leading edge, you have to buy a whole wing section. So we have to figure out ways to make it repairable. So I'm looking at how do you repair the wing skin? If the skin gets damaged, how do you replace it? Do you have to do a whole panel? Can you do one little spot like this? So I'm looking at doing a couple of repairs here. There are holes that I opened up to take a look inside the wing, see how things are going on the rest of the bonds and so forth. I was really quite surprised, considering how heavy the load was when it fell. Relatively little damage. The damage was very localized right here and here. The rest of the ribs and the skins and so forth are all in fairly good shape. There are some creases here in the skins, and I'm going to look at methods for repairing those. We obviously got a crack here that I started repairing. Have to fill that in. Anyway, so what I've done here for this repair is I have taken the same core material as used for the skins, and I've put fiberglass on one side of it only. And that leaves this flexible like this. And I've cut it to shape and size that is enough to fill the hole and then some. And as you probably saw, I have an outline marked on the skin that matches this patch. So what I'm going to do is I'm going to attach this patch here with some tape, temporary tape. I'm going to do that right now so it stays in place. And then we're going to pull you in a little closer so you can take a look at my hands as I work the repair and see how it's done. I can't promise this is going to work. These are all experiments, just trying new things. Actually, I'm going to tape this on one edge to position it just like that to hold it in place, and then I'm going to cut here and then reverse the tape and cut out the other side. Now, Kevlar can be quite difficult to, excuse me while I step out of frame. Kevlar can be difficult to cut, but if it's impregnated with epoxy resin and you're using a new blade, and it's the Kevlar 120 that I'm working with, which is only 1.8 ounces. Sorry for the bouncing around, but hey, wasn't that fun? And let me zoom you in a little bit here so you can see a little better. There we go, that looks good. Okay, I'm coming back around. Here I go. Okay, so I have an X-Acto knife set up here. It has a brand new blade in it. Let me get around on the other side. And if I cut myself, I'll just edit that out and you'll never know. Okay, as you can see, I finished clearing out the material, and I did a check fit of the opening with the patch. You'll see it's a fairly tight fit. A little bit of opening here, but some microbleeds and epoxy will fill that. I did not bother doing the wood strip at the trailing edge here. If this were for a flight where the aircraft obviously replace all the materials the way they were designed, which would include the wood trailing edge here, and then I'd do some type of splice here to make sure that they were joined together properly. But this is just a look at how you replace a chunk of the skin and get it to match the skin that's already here. So here we are, we've got a patch made for the hole. You notice that there's a slit that's been cut here, got a little cut over here. But when we put the outer skin on, I'm going to get epoxy down in there, and it's just going to seal that all up and be just fine. You got a similar type of situation here where this has been cut all the way across, but this whole area is going to get covered with fiberglass and all the way up here. Now, obviously, if we have a break in the leading edge, we need to be able to go around a curve, and that's the idea behind putting fiberglass on one side only. So this allows me to flex this to the shape of the wing, get it glued in place, and then put the outer skin on, and then we have our original sandwich panel back. Now, you might be wondering, I'm just going to put glue on the edge and stick it in there, but no. In order to make this repair structurally sound, we have to be able to transfer the loads along the inside of the wing skin. The aft wing skins are not overly critical. The inside of the skin really doesn't carry a lot of tension or compression load. It's all carried in the outer skin. But in a repair for the leading edge, that is not true. Both the inside and the outside are carrying load. So if there's a repair, we have to transfer those loads from one part of the skin to the next part of the skin across that patch. So we have the same material that's on the inside, and we need to attach this such that we transfer the loads across that. And that's where our handy-dandy aircraft plywood comes in. This is 1/64 inch thick aircraft plywood. Don't confuse this with model airplane plywood. This is a total of 5 layers thick, or excuse me, 5 layers making up this thickness. And the thickness of this wood is only 1/64 of an inch, so each layer is extremely fine. This is expensive material, but it works wonders. It's incredibly strong. And I'm going to glue these on the inside here. Let me tilt it back up again so you can see. I'm going to glue these to the inside here so that about halvesies on one side, I'm going to epoxy it to the inside of the wing skin here. I'm going to have one over here. We're going to have an issue where the rib is, of course, but the rib provides support there, so I really only need flange back in here. And then I'm going to have one across the front like this. And that will support the patch. And not only will it support the patch, it will also transfer the loads across the patch. And because this is glued to the inside of the wing skin, this will match the curvature of the wing on both sides, so that when the patch itself goes back in, those supports will actually make it bend. Now it's pretty flat right here anyway, but any curvature that's there, it's going to match because of these flanges that I'm going to add. If it were up front, this wood can bend at extreme angles, and then you lay in the other piece, and it's going to glue right down to that plywood, and there you go. You're good to go. So I'm going to cut away again on you guys. I'm going to get some of these flanges set up. I'm going to epoxy them in here. For this purpose, I'm just going to use biminute epoxy. That'll be good enough. And then I'll bring you back to see how the rest of the repair goes. Okay, I've pulled you in a lot closer here so you can see what I'm doing. I've added the flange over here where the wing skin was extending beyond the rib. The little bit of glue here and the rib itself will provide the bonding surface there. I think the optimum situation would be to make to add a stick along the edge here, cut the curve with a rib, or make a flange of some kind, would be to have more bonding surface here. In how this damages on this particular configuration, the optimum fix would be to cut here and remove this wing skin here all the way back to the trailing edge and over here, and have put one patch in the whole area that was kind of shaped like that. Would be the optimum. But for the test configuration here, this is not overly critical back here. There's no significant loads that are going to be carried here. We're going to be loading up the spar. So this is just an interesting way to experiment and see the different ways of doing the repairs. So at a rib would require removing the skin from the rib and spanning the whole area with new skin. The other thing I want you to note is that I'm using these high-tech aerospace clamps here. No, just kidding, they're clothespins. I try not to use anything that's too expensive to get this expensive work done. clothespins are great. Keep them around, handy little clamps. So what I've done here is when I put the flange on, when I glue it on, I put on a strip of tape along the halfway point so that adhesive that oozes out from the joint does not get on to the part of the flange where I'm going to have to glue on the patch itself. I got a little bit here. I'm going to try to cut that off with a knife here before I'm done. But because there's fiberglass on the patch that's going on here, it has to sit flat. So I'm going to have to get rid of that. And here I think I got the tape correct so that we don't have any running over. And just before the epoxy is fully cured, when it's in a gel state, I'll pull that tape off. So I pull the tape off when the flange is adequately bonded to the inside of the wing skin, but it's not completely set hard, so that I can peel the tape off and take the excess epoxy with. And as soon as that's cured up and I get that job done, I'll bring you back for installing the patch itself. So we're back. As you can see here, I've gotten the strip applied on this side. It's bonded well to the inner skin. And while you were gone, I thought the better of it, and I just grabbed a piece of 1/4 inch thick balsa that I had laying around, and I glued it to this rib here to provide a little bit more support for the patch that's coming in. Now, of course, the piece of balsa is straight. I don't have any templates with me. I didn't want to fiddle with it, so I just put a straight piece on there. So it doesn't match the rib exactly everywhere. That's okay. I'm going to come in with some 5-minute epoxy and with microballoons to fill that gap that's there. So here we have our ledges. We have our patch that fits. And we're going to glue that down tight to the flanges or the edges, just like that. And I'm going to be putting a little bit of weight on here like that to hold it in place and some tape. And I'm going to glue it in place just like this. I'm going to let the camera run while I mix up some glue and glue this in place, and then we'll do a little fast forward on that part. Here we are, we're back with our patch. The 5-minute epoxy that's bonding this patch in has cured initially, but it's still a little gooey around the edges, but it's solid enough to be handled. I trimmed off the edge back here. You see overall we got a pretty good fit. Tilt this up a bit, see a little bit better, get a good fit around here. Microballoons filled in at some spots, other spots are still a little bit open. So when we put the skin over the top, these areas will be filled with microballoons and epoxy. What we do have is we have a little high spot over here, a little high spot there, and then we got a dish here where it comes down and goes back up. That's because there's nothing supporting underneath. So what I'm going to do with that particular situation is that I'm going to sand this as flush to the surface as I can, get it nice and flat as possible, trying to follow the curve of the airfoil. I'll use my little sanding bar like this, and I'll probably do something like this. I might do a little bit on the diagonal, but I won't be able to do that extensively until this epoxy cure is completely solid, which will be tomorrow. And then we're going to have a little dip here when we put the outer skin on, and that's okay. For the final finish, it's almost always going to be necessary, if you want a nice smooth finish, to fill the fabric that's on the outside here. When the fabric's molded up in the first place, it's up against a sheet of Mylar, it's nice and smooth. There'll be some high spots and some low spots. We sand down the high spots, put on the cloth, and then the low spots, after the cloth is cured, the outer layer is cured, we're going to come in with automotive filler. In some cases it might be Bondo, in some cases it might just be glazing compound. Like for filling the weave of the cloth here at the edge of the cloth, you just use glazing compound. And 4, 5, 6 coats, you work little by little, sand each one down nice and smooth, and you get that all smoothed up, then you can paint it, and it's going to look almost as nice as the original. The only difference is that you're going to have a little bump up where the fabric is, and it will show in reflections, but aerodynamically it's not going to make a hill of beans difference, really, just a little tiny bit nobody'd ever notice, as long as it's all fared in nice and smooth. So not necessarily as pretty as the original, but still a flyable component. For this patch, I think everything's going to be fine. I'm going to finish up this one over here, and I'm going to do the one up front, and then we're going to deal with the spar cap over here. Don't know if you can actually see that. Oh, I went out of frame. Let me tilt you back up. So I'm going to finish up this one here. I'm going to do the leading edge one. I'm going to use the same methodology that I used here, except we're going to be using carbon fiber on the inside up front. And then for the spar cap, I'll bring you back to show you how I'm going to put the pull-true rods in there. Now, you might ask, gee, Raw, are these patches really airworthy? And as an engineer, I'd say absolutely. I've run the calculations. The loads are properly transferred. Everything should be fine. As a pilot, I might say, these, not a problem. D-tube, not a problem. So this D-tube patch that I did over here, done in a very similar method as what I'm going to use over here. This dropped on the ground, hit the ground, didn't break. Very strong. Now, as for the spar cap, that's another question entirely. It's such a critical component. Those repairs, we're going to find out. I'm going to repair this one. This is going to get loaded up. If this repair holds, then my calculations are correct, and I would say yes, that would be an airworthy repair. If I had the money or the time, I'd build an entire new section for my wing if that happened. But I'm looking at these repairs for those folks who might be out in the field at a competition. They got pranged on a bush, or somebody backed into their wing and put a hole in it. This type of patch can be done in the field. Cover it up quick. You probably just do this in one afternoon, one evening, get her done. You have a patch that looks like this one over here, but it's flyable, and that way you don't get bounced out of the competition, or you don't ruin your flying vacation one day in. Carry a little repair kit with you, and you can patch these types of things up. Spar broken, another animal altogether. But I'm going to bring you back later after I have the other patches put in, and show you how I'm going to do the spar cap, and then show you how I do the final outside sheeting or outside layer of carbon fiber. Actually, in this case, I'm going to have fiberglass back here, fiberglass up front. It'll be fine. Then we'll talk a little bit more about the leading edge repair when we do that. So you'll be back in a few seconds, and I'll be back in a couple of days. Bye.
Okay, in this next segment, you're watching me perform the repair of the lower main spar. What you see me doing here is cleaning the surface first with alcohol. Make sure we take all the oil and finger grease and so forth off. I have used a router to remove the wing skin. The wing skin is about 1/8 of an inch thick, and what you see me cleaning here is the spar repair piece. That is a series of 6 pieces of pull-truded carbon fiber that is 1/8 of an inch thick, and I've bonded those 6 pieces together with 3-ounce fiberglass on top and bottom, and it was molded on the same mold that I used for the D-tube so that it will match the shape of the spar. So the original spar is essentially still there. A small amount was taken away with the router, and the repair is essentially a doubler that is going to be bonded to the original spar, but it's going to be flush with the wing skin, and then there's going to be a new fiberglass skin go over the outside. So the spar is still broken in the middle of this repair, but the doubler will span that difference. Now there's 1 foot of doubler on each side of the spar. So the doublers are 1/8 of an inch thick, they're 1/2 inch wide. So actually I think I had 8 of them. So the full width of this is 2 inches, and 2 by 12, that's 24 square inches. And the adhesive that I'm using is good for 2,000 pounds per square inch. So 24, let's see, got 24 square inches times 2. There's 48,000 pounds of shear strength on each side. Now the maximum load in the spar is about 30,000 pounds. So 48,000 pounds per side. This doubler is not going to pull loose from the spar. The doubler itself, being pull-truded, it's 1/8 of an inch thick, 2 inches wide, and that material is good to 320,000 pounds per square inch. So this doubler is phenomenally strong and stiff, way stronger than it ever needs to be for this aircraft. It's a little bit heavy, but this was the simplest way to repair it, was to put a doubler across the full width of the spar. What you see me spreading here is a mixture of T88 epoxy. It's a structural adhesive, and I've mixed it with powdered cotton. This mixture is often called flocks or cotton epoxy, hence the name flocks. Anyway, I am essentially doing what tile layers do, as I'm back buttering the doubler and making sure I get a nice even thin layer on there with no gaps or air holes or anything like that, to make sure that we have the full bond strength available on the spar. And then I'm going to proceed and apply the same adhesive to the spar itself, and then I'm going to compress that spar in there with my weight and let the excess ooze out to make sure that we have a complete bond on every square inch that's available, no air gaps, no spaces, and ensure that it will take the full load. Now you may note when I flip this over that the ends of this doubler are actually tapered down, and you need to do that anytime you have a doubler or reinforcement, because the thickness of the material, the 1/8 of an inch thick, because these are non-isotropic materials, well, even isotropic would have the same issue. Any material that has some type of elasticity to it, if you put a lengthwise load on it and it has a thickness, at the end where that piece ends, if it is squared off, you get a linear slope of shear in that piece, and that shear begins as the material on a microscopic level begins to stretch in shear, begins to deform in shear, applies a tremendous pull on the material. In other words, the end, if you leave the end square, that end will try to peel up and away from the surface that it's bonded to, and that peeling force can be extremely high. So it's really critical that any doublers like this be tapered off on the ends to avoid failure in that peel mode. Now I'm mixing up another batch of cotton and epoxy here. You saw me fill in a gap there. There was a particularly heavy damaged area. The leading edge sheeting patch didn't quite cover it. It's a low spot, so I just filled that in with this structural adhesive and filler, just to make sure that we don't have any gaps underneath the doubler. So this is going to take a little while, so we're going to hit the fast forward here, and I'll come back when we're a little further along in the repair process. There we go. The doubler's in place, and we're ready to let the epoxy cure. I'm bringing in a piece of plywood here to distribute loads of weights that I'm going to put on top. The weights will ensure that the piece is pressed down as firmly as possible. I put on a series of these cinder block or cinder pavers, concrete pavers. How many did I put on here? 6 probably, something like that. They weigh 15 pounds piece, 10-15 pounds piece. Plenty of weight to compress that doubler down. and make sure that all the epoxy is solid, there's no air holes, and then wait overnight for the cure. And the next step of the process will be to clean up the outer surface, get rid of any excess epoxy that has squeezed out, and put on the outer skin. And we're going to see that in the next section of the video. Now I'm back indoors and ready to put on the new outer skin, which will be 3-ounce fiberglass in a crowfoot weave called 120 style. I've already roughed it up and cleaned the surface, and I'm applying straight T88 structural adhesive to the outer surface of the doubler, and that's to ensure that we have good solid bond between the new fiberglass that's coming on and the doubler that's there. This is nominally called a secondary bond or a post-cure bond, and I find it much stronger assembly when you use a structural adhesive first and then apply the next layer of laminate using standard epoxy resin. If you use just regular resin on something that's been already cured, the bond shear strength isn't nearly as high. You do have to be careful. You have to check and make sure that your structural adhesive is compatible with your laminating resin. I'm using T88 here, and my laminating resin is the super hard epoxy resin from Tap Plastics, and I've used them for many years, and I've found them to be completely compatible. You're also watching me apply structural adhesive to some carbon fiber at the leading edge where there were repairs done due to previous testing and other changes. I want to make sure that the new skin is firmly bonded to that leading edge area. And the area where the main skin, wing skin is, it's Kevlar, 120 Kevlar, and I've roughed it up with sandpaper, and if you know Kevlar, you know it's got a lot of fuzzies on it, and those fuzzies provide a tremendous bonding area, bonding surface, so it really doesn't need additional structural adhesive on it. The bond of just standard laminating resin over that roughed up Kevlar will be just fine. I'm mixing up the laminating resin from Tap Plastics here. I'm going to be putting on 2 pieces of fiberglass. One is going to run lengthwise along the spar repair, and then there's going to be another larger piece that spans fore and aft that covers up the wing skin repairs that I made. So in other words, it's kind of a giant T-shaped repair, so that over the center of the spar brake there will actually be 2 layers of fiberglass over the outside of the carbon fiber doubler. So let's hit fast forward here, and you can watch me work through this process of putting on the new outer wing skin. Here I am, I'm nearing the end of the repair. I'm applying just a little extra resin to the leading edge to make sure the cloth is fully wetted out. I'm looking for any dry spots here, putting on a generous amount of extra epoxy to make sure that those areas are fully wetted. Then I'm going to come in with my squeegee and essentially scrape it clean. We really don't want to have excess resin on the surface. Don't want the cloth to be dry anywhere, but extra resin is extremely heavy and it doesn't help the strength any. So I'm going to go through here and start wiping off the excess resin and checking for any other spots that are sticking up, and I'm going to scrape this fairly firmly so that I'll look at this under the shop lights and I'll look for evenness of the resin. I don't want to see any glossy spots. I want to see even finish of fabric across the repair. Keep in mind that 60% of a composite aircraft weight is the resin that you used to glue it all together. So excess resin is a bad thing. You're adding a lot of aircraft weight for no additional structural strength. And I'm making sure that I got it all fully wetted out. Then I'm going to scrape it with the squeegee somewhere along the line here and take off the excess. And you'll see in the next segment that it ends up with a nice, smooth, even repair. So let's watch the finish here, and then just in a few moments we're going to be moving on to the final segment.
Welcome back. Here we are looking at the finished repairs to the aft skin of the wing. I am quite happy with both of these repairs. They're very solid. The joining method of using the plywood on the inside to join up the patch with the rest of the skin works really well. It is solid, and the outside is covered with one layer of 3-ounce fiberglass cloth, and it's as tough as the original. I think that if a aft skin got damaged on the aircraft, this is a very viable repair. This would be fine, airworthy, all of that. Some things to note: obviously somebody would want to come in with filler on the edges, actually over the whole surface, put glazing compound on here, sand it smooth, polish it out to blend it into the rest of the wing. I did not spend a lot of time smoothing out the patches with the surrounding surface, but that'd be quite easy to do. Lightweight filler, a little work with a sandpaper, smooth them out, blend it together. That would help maintain the shape here. A fastidious person would print out templates for the airfoil and come in and run the templates across here and make sure that they're matching the original airfoil. One thing of note is that this patch I had run to the trailing edge, and this one I stopped short. And I would have to say, when you're only this far away from the trailing edge, it's probably just a lot easier to make a patch that runs all the way to the trailing edge. Just cut this all the way back here and put a new little piece of wood in here at the trailing edge. Much easier repair and probably stronger because you're reattaching to the rear spar instead of carrying the load across the skin. For those of you who saw my dog walk through, that's Charlie, the beagle. He always helps out on the videos. Right, Charlie? Anyway, I was also quite pleased with the repair method of the spar. For this particular instance, I would not recommend it to fly on it, but the repair seems to be solid. The pultruded carbon fiber rectangles that I put in here are actually 4 or 5 times the strength they need to be. This concept of removing the foam and going down to the inner wing skin and the spar itself worked out quite well, and the repair actually nests in where the foam used to be. It'll be interesting to see how this repair holds up during the next round of structural testing. Wouldn't recommend it for flight quality. If this were on an outboard portion of the wing and you were able to put in the carbon fiber rods on both sides of the spar, both on the inside skin and on the outside, and say it was 8 times stronger than it needed to be, I'd say that's probably okay to fly on. Now, as to leading edge repairs, if I can spin this around for you, here I just kind of patched up. Let me get this back in frame. Hang on, here we go. Whoa! this was a very crunched up section of the leading edge, not viable for flying on. I think that one of the common damages to the wing is going to be hitting bushes and trees and smashing in the leading edge D-tube portion. And I think even though I did a repair here, this repair went well, carbon fiber on the inside, very solid. I think if you had damage somewhere between the spar and this area near the leading edge, you can take this piece of foam that has carbon fiber on the inside and curve it to match, blend it in, you'd be fine. Transfer the loads across to the rest of the D-tube. This is a very solid repair. I'm happy with that. You'd fly on that. But if you took a direct hit right on the leading edge and smashed this in, I'd say that this whole section would have to be cut out like this, remove the damaged portion, mold up a new section of the leading edge, go to the molds that you hopefully kept, mold up a piece that fits in here, mark off the repair, and then join it in the same way that we did the other patches with a lip on the inside of plywood, and then bond it in place, and then fiberglass over the outside, and then smooth it out with filler. And I think that would be a viable repair on the leading edge. So I think that the expensive, critical components of the wing can all be repaired, save the spar. You could probably do spar repairs outboard. I certainly wouldn't do it inboard. Given the critical nature of the component, probably just better to build an entire wing section. Now that is one of the advantages of this wing coming in 6 parts total across the side, excluding the cockpit area, is that if you do bump into a bush or a tree or a post of some kind and damage the wing badly, crack a spar, you're not buying an entire new wing panel on that side. You buy one, but you build one subsection of the wing and save a lot of money and time and get back flying. The outboard portions would probably be fine, or the portions that weren't damaged. Now, I did do, I'm doing some work at the root end here. I'm testing new, I'm looking at some new root fittings here. So I did a complete spar replacement here. So this is actually going to be a very good test of this type of spar repair method, where I'm removing the foam and bonding in the pull-truded carbon fiber rods. And I also did a patch front and rear. I had to remove these areas so that I could get in and remove the spar cap portion here to put in the new root fittings that I want to test. So this is going to take maximum load that you'd ever experience in flight, and it'll be a good test to see if this type of spar repair really does work. I also did, this can be difficult, but I'm going to have to flip this over here and maybe spin it around. Get it spun around. I did do a leading edge sheeting repair here from the spar up to here, and putting foam in here with carbon fiber on one side, nothing on the other side, and curving it to match, and then fiberglassing. All worked out quite well, aft and front. So you can match this type of curve. I didn't do a really good job of filling in here for the patch, but that's okay. You could fill after the fact, you could fill before. This is certainly an area where you'd want to use templates and make sure you have the airfoil matched properly. But it's a solid repair. This would hold up just fine. So, with exclusion of the spar caps, I believe that just about any portion of the wing is repairable, which is critical to making a viable, usable aircraft. And I hope you come back to watch the testing of this wing section. We're going to be loading it up this weekend and see how the new attachment fittings work out. This is actually a backup design. As you can see, they're quite beefy. These are carbon fiber that 1/2 inch thick here, about 3/4 inch thick here. These 1/2 inch bolt here. These are very beefy. These are way overbuilt. This is my backup methodology. I know that these fittings will be secure, but they are quite heavy. Total, there's probably 4 or 5 pounds in the whole aircraft weight that I don't want to carry, but these fittings would do the job. So I'm going to try another alternate method after this to see if I can make it a little bit lighter, save a couple of pounds. But these are solid, actually version 2 backup for the root fittings. If the next one that I try doesn't work, then I'm going to fall back to these and use these for the final design. So come on back, watch the testing, and thanks for joining me.
Bye now.